we're continuing it, but we're doing the fundamental theorem of calculus, part 1. Alright, so part 1, the definition of part 1 is if f is continuous on a closed interval from a to b, then the function f of x is equal to the integral from a to x of f of t dt. Alright, so looking at that definition, one of the things I want to point out is this has to be an x on top. We're going to do some manipulating to get it to x. And a is going to be a numerical value. Alright? Okay, starting there. Then, I want to add to this definition. It has a derivative at every point x within a to b. And df of dx is equal to the derivative, the integral from a to x of f of t dt, which equals f of x. But okay, so a lot of mumbo jumbo there, isn't it? Yeah, you think so? Super fun. All right. So here's example number 1. The first few problems in your homework are really going to be just this easy, okay? All right. Yeah, that's an equal sign. Alright, so your directions for 1 through 19, okay, are all going to say just find dy dx. But the first few are super easy. So I want to explain it that way. So they give you that y equals the integral from, let's say, 2 to x of 3t plus cosine t squared dt. Looks crazy, right? But think about it. What it wants is this right here tells you it wants the derivative with x in it. Where in this problem is the derivative? It's inside the integral, isn't it? So our answer, dy dx, equals, or y prime equals, 3x plus cosine x squared. No. Okay. Well, I told you some of them, there's more to them. Just the first 3 or so are like exactly like this. Okay? Let's do one more like this. Make sure you guys don't think I'm crazy here. Let's find dy dx. Given y equals the integral from 4 to x of e to the u secant u du. Again, it wants us to find the derivative with x in it. So, we take what's in here, and we plug in x. So, dy dx equals e to the x secant x. This literally is what we do for 1, 3, 5, 7, 1, 3, 5, and 7. That's all you do. Okay? We're ready to move on. Okay. So, it only works if this is just an x here. Well, what if it's not? So let's say I have something like y equals the integral from, how about 1 to x squared of cosine t dt. That's not an x, unfortunately, right? So what I want you to think about is the fact that we're going to do a form of the chain rule. We're going to replace this with u. We're going to say u equals x squared. So then du, of course, equals 2x. All right. So now we have to change it into u's in there to begin with. So this actually is going to change to cosine u du. Okay? But our final answer wants it to be dy dx. So what do you think we're going to do with the u and du? Plug in the x squared and 2x. So we get the cosine of x squared times 2x, or 2x goes in front. That's it. Okay, so it's a form of the chain rule. All right? Form of chain rule. And you guys learned that so well, this is going to be super easy. Okay, so let's try example number 3. I want you to find, again, dy dx. Find. Given y equals the integral from 2 to 5x of the square root of 1 plus t squared dt. All right, so as you can tell, that's not an x right there, right? So we're going to say u equals 5x. This becomes my u. du equals 5. So I'm going to rewrite this with u's in it. So I have the square root of 1 plus u squared du. All right, still doing good? So now I'm going to plug 5x in where u is and 5 in where du is. So I get the square root of 1 plus 5x squared times by 5. So really I can write my 5 in front of that square root. The square root of 1 plus 5x times 5x is 25x squared. Okay? Doing all right? Any questions out there? Can we make it harder? Let's do one more on the same level before I take it up a notch on you, okay? Okay. How about, here's example number 4. And again, I want you to find dy dx. And let's say we have the integral. So y equals the integral from 0 to x squared of e to the t to the third dt. All right, so we have to do a u substitution for that x squared, right? So u equals x squared. Du then equals 2x. Now go ahead and replace your t's with a u because that's what would have been here, right? So we're going to have e to the u to the third du. So now to get our dy dx, we have to replace that stuff. We have e, our u value is x squared raised to the third times by 2x. So now how do we simplify this thing? Yep, multiply the exponents. And I can move that 2x in front, right? So 2x e to x to the 6th. All right, not too bad. We still have a little bit more to go, but it's not too bad. Taylor, you're yawning on me. I totally get it. Example number 5. Again, let's find, and we're going to amp this up a little bit. Find dy dx. And I'm going to say y equals the integral from 5x squared to 25. And in here, let's put t squared minus 2t plus 9 over t to the third plus 6. So, first thing is we know it has to go from a number to an x, right? So we can flip it by putting a what in front? A negative. Awesome. So that's step number 1. Y equals negative. And we're going to flip this from 25 to 5x squared. And I'll write it all out again just so you have it. 6, and of course I forgot my dt back here. All right, now there's a problem with that top bound, so we have to do a what? Good. So u equals 5x squared, which means our du equals 10x. Now we're going to replace all of those t's with u's. Okay? So we have negative, and I'm going to put it all in parentheses, u squared minus 2u plus 9 over u to the third plus 6 du. So we're totally good with that step, right? So now we're going to plug those u's and du in and simplify it all. So guess what comes in handy? Our awesome algebra skills. All right. So we're going to go negative, parentheses, u is 5x squared, minus 2 times 5x squared plus 9 over 5x squared cubed plus 6. We're timesing it all by 10x. All right, I'm going to move my 10x out in front if you guys are good with that. So I'm going to start with negative 10x out in front. In my parentheses, 5x squared, 25x to the fourth, minus 2 times 5x squared is 10x squared, plus 9, over 5x squared cubed, 125, x to the 6th, plus 6. Now you can technically leave it just like that with the 10 out in front, or you can distribute the negative 10x through the top line. Leave it. It's up to you. We're leaving it. All right. So, what do you think so far? You like this better than yesterday? Oh, I'm not done. I'm not done. You guys got too excited on me. Okay? Sometimes it has variables on both ends. So what are we going to do about that? Sometimes it has variables on both ends. So if the integral has variables on both bounds, the integral integral must be split. All right, so here is my example. And I'm on example 6, 7. What am I on? 6. Thank you. All right. So let's say I have y equals the integral from the square root of x to x of, huh? Let's go, let's just say, we'll do an easy one, sine x, or sine t dt. All right? So we have to split this. What we're going to do is the big bound first. Okay? So the first integral is going to go from 0 to x of sine t dt minus, because you're going to take the big one and subtract off the other one, the integral from 0 to the square root of x sine t dt. Okay? So in the first one, that's like problems 1, 3, 5, and 7. We just get to plug x in, because it goes from 0 to x. The first part of our dy dx is sine x minus. Over here, our u substitution is for x to the 1/2. Our du then, 1/2 x to the negative 1/2 or square root x, right? All right. So, and I'm okay if you guys start to just do this with it. You know what I mean? Because it's not just an x. Right. All right, so when we replace it, we have sine. Our u value is the square root of x. Our du value is times 1 over 2 square root x. So technically, you should move that to the front. So we'll have sine x minus 1 over 2 square root x sine square root x. Yeah, it's pretty much the same thing. It's just if it's two bounds, that, yeah, you got to split it. All right, last thing I need to talk about. Last one. This is 21 through 27. Okay? These are even easier. We talked about constructing a function. And you're going to be given, for example, let's say y equals the integral from a to x of f of t dt. I'm losing my voice, sorry. Plus c with given conditions. All right, so this is how it works. You guys are going to like these. Example 7. If dy dx equals e to the x tangent x and y equals 6 when x equals 3, we'll say, here is what we do. We have the integral, or y equals the integral. Whatever this x value is goes at the bottom of the integral. Goes to x. Then we change what's inside. We have e to the t tangent t dt. And then we got to talk about this y value. This book puts plus 6 at the end. A lot of books, just so you know, for future reference, puts the 6 in front. So y equals 6 plus the integral. Either way, it's exactly the same thing. A lot of times on the AP test, it's written this way, just so you realize. So I don't know, do you want me just to write it in front so we get used to it? Okay. So 6 plus the integral from 3 to x of e to the t tangent t dt. And that's all you do. Okay, you put your y plus the integral from whatever the x value is to x and replace it with t's. Okay? That's it. I'm done. Oh, the x is the bottom bound. Okay? So when you put it, because they don't give you this part right here, you're writing that. So when you write this, whatever this x value is goes at the bottom to x. Okay? All right. Yes. Before Trayton asked. No, I'm just kidding. Go ahead.